So good morning and afternoon, everybody. Thanks for attending this week's Senstar e-seminar. So this week's session is how to use perimeter protection with general purpose distributed acoustic sensor, which is quite a mouthful to say. So my name's Todd Breezewell. I'm one of the product managers at Senstar, which is a world leader in video management and perimeter intrusion detection solutions. So with me, I've got Stuart Dewar, who's another product manager at Senstar. He'll be presenting, and I'll be helping out as moderator for this particular e-seminar. So the lines will be muted during the session, but if you do have any questions, just submit them into the questions window. It's in the lower right-hand side of the GoToMeeting app. It's just above the chat feature window, and I'll be monitoring it, and I'll be answering the questions directly, or I'll just queue them up for Stuart to answer, when time's appropriate. So without further ado, here's Stuart Dewar, and he'll get things started.
Okay, thank you, Todd, and good morning, good afternoon, good evening from wherever you may be to tune into this webinar. We thank you very much for your attendance. So as Todd mentioned, we're going to talk about distributed acoustic sensing in general a little bit, and then more specifically, Senstar's offering in that domain, which is our FP1150 system, which actually we're announcing today some fairly dramatic enhancements in the performance of that system. So here's what we're going to go through. We're going to start with the basics, like what is this technology, define it essentially, a little bit about Senstar's history in distributed acoustic sensing, a little deeper into the principles of the technology, our FP1150, what it brings to the table for people to use, the range of applications it can cover, how we integrate with video and security management systems, new pricing model that we're introducing again today that gives flexibility in pricing and reporting systems. And finally, as Todd mentioned at the end, we'll take up any questions that have come through during the course of the webinar. We're more than happy to answer all the questions we can. So what is distributed acoustic sensing using coherent OTDR principles? So that is a mouthful in itself. We'll break it down. So optical time delay reflectometry is the basic principle of using a pulse of light, send it down an optical fiber, and monitor and measure the reflected signal that comes back to the source. That's the OTDR part of that equation. Coherent means that the light that's being transmitted down that fiber, it's not just any old light. It's not a typical LED, it's not a low-cost laser, it's a very pure laser light with a tightly controlled frequency of a single pure wavelength. And that wavelength is stable from one pulse to the next, so it never varies over the course of time. Acoustic, people put the acoustic term into the equation, referencing the fact that the mechanical frequencies of vibrations of the system being monitored, the fiber being monitored, can be analyzed over anything from almost DC to several thousand hertz. Potentially even more, but from DC to several thousand hertz gives you the range of coverage that's adequate for almost any detection application. Distributed, we say distributed acoustic sensing, referring to the fact that that sensing fiber can be tens of kilometers long, miles and miles, and the return signal sampled at thousands of points over that fiber. So it becomes, some people will use the phrase a distributed microphone, 1,000 or several thousand microphones in a sense along the length of that cable. So that's really the definition of what we're talking about today. Now, Senstar has been in this business of such systems now since 2005 through the acquisition of Attenuation. At that time, we introduced our first distributed acoustic sensing system, which was at that time based on interferometry principle. Then later, 2009, we introduced distributed acoustic sensing based on our current technology baseline, coherent OTDR principles, which have numerous advantages we'll get into over the next few minutes. 2014, that was the date of the acquisition. 2018, we introduced our first generation FP1150, which integrates into one single 4U rack-mountable unit, the sensor components and the server components that do the higher level processing and establish the connection to the outside world, all in one box for convenient racking. And 2020, matter of fact, today we're introducing our second generation FP1150 with greater range and greater range of applications. So a little bit into the principles of operation again. In the previous slide, we mentioned that the light is shone down the fiber, And at some point on the fiber, if there's a disturbance, that changes the amount of light going back to the source. That is measured and monitored and is the signal that the system is responding to. In fiber optic sensing, there are different technologies in use that exploit different behaviors of the fiber, essentially. And in the chart, it shows the different responses that will come from the fiber. And in the middle is the so-called Rayleigh scattering. And what is being shown here is the fact that in this type of scattering, it is the largest type of scattering that comes back from a fiber when light is injected into fiber optic fiber. And it comes back at the same frequency as it was sent down. So the wavelength or the frequency of light doesn't change in this reflective process. Unlike other types of reflective processes people may have heard of, Brilliant, Raman, which are not so good for distributed acoustic sensing, have some value when it comes to temperature sensing, but doesn't help with the distributed acoustic sensing challenge. How do these disturbances happen at a very low level? So the laser light is transmitted into the fiber optic cable, represented here. And in that fiber optic cable, even though it's super pure, very low attenuation, there are still imperfections in that fiber optic cable that create reflections back to the source. These imperfections come from minor changes in the density of the glass, minor changes in the reflective coefficient of reflection of the glass. And anyway, so there's lots of these points. And from every point, there'll be a tiny amount of reflected light going back to the source. And because this is laser light and it's very pure, the light is summed in a phase-sensitive manner. So the light, any given reflection may add to the others, or it may subtract from the others. So we'll blow down into what that looks like by looking at we'll pick two of these little reflective points at random, and we'll show you that in this little vignette, at first, their phases are in line, so they're going to add constructively to the signal that heads back to the source. Now, if that cable is perturbed by even the slightest, we're talking like sub-micron elongations or contractions of that fiber optic cable, all of a sudden, for these points, you're not getting constructive adding, you're getting destructive adding, and the light that's being returned from that particular point along the cable will be reduced. So that is how the system works, essentially. That is how the small perturbations, changes in the length of the fiber, translate into different magnitude of light being reflected back at the beginning. And in this diagram also kind of explains, people might say, well, why can't I just take an OTDR, hook it up to a fiber and get the same response? And the answer is in this chart here. They'll never get the same degree of phase-sensitive addition of the reflections because the light that comes out of a standard OTDR has many wavelengths. You don't get this interferometric process happening. So that's a little bit of a deep dive into what is happening in the system. And it essentially explains that no matter what the source of the vibration is, it translates into the elongation or contraction of the fiber, and that is what's monitored by the system. One thing that comes out of that explanation is that no signal is required from the end of the optical fiber. So this system always works up to the point of a cut, and that's very helpful in practical real-world scenarios to provide high availability and integrity of a deployed system, as we'll talk about. So what is Senstar bringing to the party in terms of our system? So we have the FP1150 4U sensor with two independent sensor channels built into one box. For perimeter applications, this is a new for today, we are offering capability to go up to 40 kilometers almost 25 miles per sensor side. For your core classic perimeter detection applications of fence, buried, because we can put this fiber in the ground and detect people walking over it, or wall top applications, where we can put the fiber at the top of the wall. So up to 40 kilometers in that scenario. Now, for what we generalize as TPI, which can be either for pipeline applications or data conduit monitoring applications, we can go up to 50 kilometers with the same unit. And from an integration perspective, there's nothing additional to rack and stack to get the integration to the outside world. You don't need a dedicated external server. We install a very lightweight integration package we call Network Manager on the FiberPatrol processor itself. And from there, we can establish SDK level connections to SMS VMS systems. We can close relays and drive that into alarm panels if that's the chosen integration approach. Or we can trigger programmable ASCII strings to the head-end system to interpret. So a lot from one small box. Now we have different deployment configurations because we have those two independent sensor channels coming from the one unit. You can use the two sensor channels independently, as shown here. And this would be perfectly good if one is trying to maximize the amount of the license that you've system is licensed for, or if you have a perimeter that doesn't close, like this nice picture closes, but you might have a waterfront area that where there is no passage of cable, there is no fence, or some other obstacle that doesn't let you close the perimeter as such. So you could use the independent sensor mode for that. And that would be a fine way to do it. Now, what most people will want to do, and what this system supports brilliantly, is the so-called, what we call the cut immune configuration. So if you look carefully and follow the paths, one fiber is essentially going around the system in a clockwise direction, whereas the other fiber, from the box, is going in the counterclockwise direction. So basically, every point on that perimeter is covered with two fibers, and the system is correlating the two responses. It's not giving two alarms to the head-end system when something happens. It recognizes when it's the same location and gives one alarm. So it does that correlation function for alarm management purposes. So this is and the benefit of this system is that if that system, if the cable gets cut somewhere, the perimeter is still covered fully by either one fiber or the other, because of the A, having the two fibers, A, going, managing the deployment, in terms of the direction that they're coming at. So this is the FiberPatrol FP1150 cut immune configuration. So what can we do with this system? As we've talked about, we can deploy it on fences. If you have a decent quality chain link fence, we can, with a single pass, give you up to 4.3 meters or 14 feet of coverage. And for fence applications, you can get from the one box up to 80 kilometers of coverage total, or 40 kilometers in the cut immune configuration. And we will provide a detection accuracy of 4 meters. And the zoning is done in software. Not mentioned here on the slide, but in your software, you can define where zones should start and stop based on the down cable distance. And you can have up to 1,440 zones. So all the zones you could ever ask for, really. Buried perimeter detection. When buried for perimeters, we can detect walking, running, crawling, nearby moving vehicles. We can detect heavy vehicles, simply the engine running. So, somebody coming up to the perimeter that shouldn't necessarily be there. We can detect tunneling activities and the depth of to which we can detect the tunneling activities can be augmented by burying that fiber cable deeper and deeper into the ground. And of course, we can detect if there are tunnels in the ground within 10, 15 meters, we can detect operation within the tunnel. We can't detect the simple presence of a tunnel, but we can detect either the activity of building it or people or equipment moving through it. And this coverage is up to 80 kilometers per system. And again, for plus or minus 4 meters of detection accuracy. Wall top applications. Walls are challenging to protect, and the fiber deployment of the fiber and in this wall top is one of the few effective ways to get detection on the top of a wall, short of turning the wall into a fence, by putting a short piece of fence or some kind of topper on the wall, which is fine. But in some scenarios, people don't want that. So think of a gated community where you've got a nice wall around that gated community. People don't want to see a coil of razor wire or a little mini fence sitting on top of the wall. They want protection on their wall. And typically they want foliage. So they don't want to have to cut back or the trees dramatically or eliminate them. So this wall top deployment is an effective means of providing perimeter detection in that scenario. Basically, that sensor is going to be touch sensitive. So anytime somebody puts a ladder up against that wall, throws a rope over, climbs over, hits it with a body part, they're going to be detected. And you can do this with either one run of fiber on one side or two to essentially improve the probability of detection by putting it on the inside too. And the picture is a little deceptive because it looks like the cable is set back inside. It's really right kind of flush with the edge of the wall, and can actually, we would actually recommend to have it outboard a little bit, by an inch or so as well, if that's possible. So that's the wall top application. Pipeline TPI, millions of kilometers and miles of pipeline around the planet. Some of them are in dangerous scenarios and some of them at risk of being attacked, either to be tapped into or through accidental digging, for other utility purposes. So with that FiberPatrol system, we can put the fiber optic cable adjacent to the pipeline, typically over it, at 1 meter to one side, and we'll detect digging, manual digging, machine digging. Depending on the cable positioning exactly, we might be able to pick up pedestrians, we will pick up vehicles, and of course we'll detect any direct tapping or drilling into the cable. The advantages of using such a system for pipeline TPI is that for the distance scale of pipelines, the system is relatively inexpensive, doesn't require any field infrastructure, it's inherently safe. If it will never cause an explosion if there is a leak of gas or pipeline fluid. And in this, for the pipeline protection scenarios, we get up to 100 kilometers of coverage per sensor unit. And because the system is general purpose, you can do what the picture is showing here, whereby this cable is being used primarily in this little vignette for the pipeline TPI detection application. But at the above ground infrastructure points, which could be valve stations, pump stations, power stations, that same cable or the same fiber path can be deployed on the fence to give coverage of the above ground installations with no infrastructure other than this fiber required at this point. No communication connections, no power, no grounding, no nothing. We can protect data conduits. Again, there are some very, very critical data communication conduits in the world, and the criticality of that increases daily as people become more and more reliant on everyday high bandwidth communication to the cloud. We all want to move our stuff to the cloud, and that cable better not get cut or damaged that connects us to the cloud. So with the FiberPatrol system, we can use an unused fiber that's in the cable if it meets some basic performance requirements. And again, analogous to the pipeline case, we can get early warning of digging or the presence of a digger that might incidentally dig into the cables. And in some scenarios, you may want to protect your cables from deliberate tapping, and we can do that with the FiberPatrol system as well.
Stuart, I got a quick question. It appears that the system can be integrated to almost any head-end system. Is that a true assumption? He was thinking more in lines of a system like the Honeywell Vindicator system, for instance.
So yes, it can be integrated to almost any system, and we'll talk a little bit about integration actually coming up before too long, about what the options are there. So, so I guess to move on through the presentation then, in addition to the application types we've already talked about, we can also cover some general monitoring applications. There's a growing interest, as illustrated in the first figure there, of ingress protection onto active rail lines. You know, around the world, there's that picture repeats itself hundreds, thousands of times, where you have a busy road next to a railroad, and if there is an accident and a vehicle ingresses onto the rail track, you know, you want warning of that event automatically so that the train can be stopped and doesn't plow into that accident site and make things worse for everything. So ingress monitoring and detection of blasts in vehicle tunnels. That's obviously a serious concern, and the fiber allows you to do that, again, with relatively little infrastructure in your tunnel. Cover miles and miles of tunnel with simple fiber, no electronics required. Integration, so I guess touching back to that question. So our integration channel is the so-called network manager software, which can run either independently or can run on the 1150 to keep things simple. So we have an SDK for that over the course of time, probably 50, 60 different, you know, video management systems or SMSs or PSIMs have been integrated to. We make that SDK available very freely. You know, any qualified inquirer will get it free of charge. They'll get support to the integration, because obviously we want to support that activity. Naturally, the system is integrated to our own software, our own Symphony video management system, our own StarNet 2 security management system, our AIM lightweight security management system. And we also have general purpose ways of triggering the outside world. We can send, you know, programmable ASCII strings, and then we can also close relays to indicate alarms and the diagnostic status of the system. Here are some of the integrations that exist today. It's not a complete list, but these are, you know, some of the main vendors out there. Honeywell is there. That actually is representing the integration to the Honeywell EBI system. So not the Vindicator, but would love to work with Honeywell to get that done. Sensor unit redundancy. So last but not least, in terms of the features of the system, great system, you know, handles huge perimeters. There is interest in having some redundancy in that coverage. So, for instance, you could use a redundant sensor unit. Now, when you have a redundant sensor unit, you don't need really extra cables on the fence, because there's almost always extra fibers that you can use to put the redundant system in place, or to give you the fibers for it. And you could theoretically imagine having a separate cable for the redundant system, but it actually does you very little good, because most of the scenarios where you can imagine a cable being cut, you know, if one cable gets cut, the second one's going to get cut. So most of the time in the redundant scenario, redundant sensor unit scenario, the extra fibers are run through the same cable. Now, when it comes to integrating that into the head-end system, DMS, SMS, if you just kind of do it in a simple-minded way, it becomes a bit of a challenge, because this system can get, you know, confused, so to speak. You know, which system do I listen to? Do I listen to both? In which case, everything gets reported twice. and that's just going to be chaotic for everybody. So the answer from Senstar is, well, don't do that. Put, in this case, a dedicated network manager server in place, which can also be made redundant if the criticality concerns lead to that solution. And configure in there this virtual sensor that we've created that is the redundant sensor unit. So basically, the redundant sensor unit will attach to two physical sensor units and sort out the alarm management. It'll send the alarm from whichever of the system is healthy, and if they're both healthy, it sets it from the primary. And it will even stitch together alarms if the fiber has become discontinuous and one system is monitoring one portion of the perimeter and the other system is monitoring the other. This redundant sensor unit will patch that together and present the right information to the head-end system. So in the end, it looks like this. To the system, he thinks he's seeing one, Uber sensor that's doing all the alarm management, and the integration approaches can, all those same integration approaches continue to work. You can have the SDK level integrations that we talked about, the ASCII, the Ultralink relays, et cetera, et cetera. It's all still there. So moving on, and we're getting too close to the end, we have one more innovative and unique thing to talk about, where we're now pricing the systems essentially on a per meter basis. You buy a box, you will know the inherent capabilities of that unit, what distance it can cover, and then you buy licenses to activate it. And what does this do for you? Basically, it minimizes pricing discontinuity against distances. So if you have a system that it's about 5 kilometers and you don't know whether it's quite under or it's quite over, and traditionally it would have been potentially quite a leap, to go across a pricing boundary in terms of the system capabilities, but now it's more progressive and contiguous. The second point is that if you buy a system and it's good for the full 40 kilometers, even if you only use it for 20, 25 up front, you'll know right from the get-go that that option exists for you to extend it later on. And by having this common approach, it'll simplify sparing for scenarios where you've got a fleet of these around a number of electric utilities or around correctional utilities that are facilities. You just have to have one spare that will cover the range of distances. So what does this look like? Basically, we would have a 5 kilometer capable unit and licenses associated with that 5 kilometer capable unit, and then a 40 kilometer capable unit, which obviously is going to be, the base price of that is going to be more, but then you license it again as you need to for the system in question. And here's the license for that. So that's the linear pricing model. So with that, we're coming to the concluding slides. So we've talked about what is DAS sensing, what is OTDR, a little bit about Senstar's track record, a little bit of a deeper dive into the principles of it, what we're putting on the table with our FP1150, the range of applications, integration, pricing model. Now we have time for any questions.
One question that had come up that I did send privately was, and maybe it's something you could talk about, is how susceptible is the system to nuisance alarms?
Well, it depends on the environment, but for sure, any fence mounted system, particularly is where wind-induced nuisance alarms are possible. And with the system, because it's a ranging system, we have many algorithms that we run to minimize to the greatest extent possible nuisance alarms from wind sources. And I guess two of the things that come immediately to mind are that the system is monitoring like every individual point along the perimeter individually, so it doesn't accumulate wind noise over a long length. It just looks at what's happening at a given point on the cable. And that helps to reject a lot of wind noise compared to older generation systems. And the next element is our specific environmental compensation algorithm that looks at wind noise along the full length of the system and essentially uses whatever that level is as the baseline for putting the threshold against disturbances. So with that, largely rejects wind-induced noise and makes the system very effective other than when a hurricane comes through, right? There's no way to say that you will never get a nuisance along from wind.
Okay, I've got somebody else who sent out a few questions. First one would be, same S1 or S2 channel can be used for mixed fence, buried wall top applications?
That is an excellent question, and the answer is yes. Yep, you can. You don't have to split the applications on the two fibers because in the setup of the system, we for different range and distances down fiber, we tell it what the medium is, and then the algorithm used for that section is the optimum algorithm.
Okay, the second question was availability of smaller 10 to 15 kilometer sensor, or is it covered by price model?
It's covered in the price model, so that's exactly, again, another good question. But yeah, we'll have an effective competitive price for 15 kilometers worth of coverage by selling you that one box that's good inherently in the optics for up to 40 kilometers. So you'll have the option to extend it down the road, but the price you will pay up front will be appropriate for a 15 kilometer perimeter.
Right. And that third question was depth of sensor burial.
For perimeter detection purposes, it's not terribly sensitive to the depth. So we would say anywhere from 30 to even 75 centimeters. So like 12 to a foot to 2 foot, kind of like for perimeter where you want to detect footsteps. For pipeline, we typically put it a little deeper, more like three feet under the ground. With data conduit protection, obviously it's in the data conduits wherever they are.
Okay, and is the fiber special or can it be a standard single mode fiber? And as well, maybe comment on the intrinsically safe aspect of the system.
Yeah, excellent questions as well. So this is standard, we would call it telecommunications grade fiber. So there's a few critical parameters that it needs to satisfy. Needs low attenuation for one. We highly recommend the so-called loose tube construction, where the fibers have a secondary inner tube around them, and that it be gel filled. The gel fill is a must, so that the vibrations are transmitted effectively from the medium into the fibers themselves.
And does it integrate with an auto tracking PTZ?
Yes and no. Yes, we can transfer the range information. The hesitation is more, the question is more on the head end, the SMS or VMS, than our system. We can transfer the exact location information, like to the meter, to security management system. Normally, that can be used for visualization of where the intrusion is, so that you can put a little dot or star on a map, so the security operator has this better situational awareness and a visualization. If the system has the means internal to it, the system being like the VMS, that same specific range information could be used to point a PTZ camera at a finer resolution than just the zone itself. But to be honest, 99.9% of people point that PTZ camera based on a zone. So they will break that perimeter up into zones of, say, 50 to 75 meters, and that's what controls the PTZ camera.
What is the max distance between the fiber and human sensing in buried fiber, I believe the question is?
Going from memory, it's anywhere from 3 to 5 meters typically, for a walk, a standard walk in that range, yeah.
How many fibers to protect current FO infrastructure? Can you get back to that slide?
So one fiber, We just need one fiber. That would be an unused available fiber, so that we would need access to both ends. Obviously, we need to hook one end up to the sensor, and for general good housekeeping purposes, we would put a terminator on the other end, even though it's not strictly necessary. So not a huge burden, to protect the data conduits, one fiber.
Okay, and with the wall top application, in your picture, it showed two cables, one on the front side, one on the back side. Is that needed?
Excellent questions. Really, one is essential, obviously. The two gives you better probability detection. And so, essentially with this wall top application, I guess just to be clear, we're going to detect when somebody hits that cable, again, with a ladder, with a rope, with a body part, whatever, right? So by having two runs, you just give yourself a better chance. I mean, obviously the first one, you put that one run on the outward facing side. Again, it's not really that, if you're installing one run of fiber, putting the second one in place is not so expensive, and we would recommend that if it's possible. It's not necessary.
Can the system be used to sense earthquakes?
Yes, it can. I mean, it will actually, and we've seen it do that. It's not part of Senstar's core expertise to understand or try to compute the magnitude. It's just not part of our wherewithal.
For pipeline application, can the system detect a leak in the pipe, assuming it is a gas pipe?
Potentially, but it's not specified for that purpose. We would detect a leak if the leak is of such magnitude that it creates detectable vibrations, which many would, but we are offering it primarily as a third-party interference solution.
And in a cut immune configuration, how far apart would you install the two detecting lines?
Okay, that's a good question. Maybe I'll go back to that. Those fibers are most normally, and we specify it as such, in the same cable, which is good because you don't need a second cable. And there's really no advantage of using a separate cable. And you're almost going to, if you have a cable with one fiber in it, you're almost guaranteed to have multiple other fibers. So we would put that fiber, that second fiber for the cut immune, in the same cable, right in the same tube, in fact, to that, so that the progression of the fiber, both fibers have the same path length around the system.
Can you use armor-clad fiber for on-fence application?
Yeah, for sure, definitely. Yeah, yes. Yeah, and that would be commonly done in correctional environments. And one flavor of application we didn't really portray was deployment along razor wire, which for sure, if you did that, you would want the armored cable.
Buried cable can detect tunnel digging, but large vehicle will only be detected with engine running? Question mark.
No, I might have misspoke there. I mean, obviously, a large vehicle moving would be detected, but possibly even not moving or parked, we would detect that as well from the engine.
And what is the end terminator?
In optical terms,
it's an isolator. Essentially, light goes in, doesn't come out.
And you said there is some possibility of integration with Honeywell. Which Honeywell products can be integrated, and which way? Is it a software or hardware integration?
So any of them can be. The integration that exists today is for Honeywell EBI, Electronic Building Integrator. Others, certainly can be done through an SDK level integration. I would love to see that happen. And there's always the fallback with hardware. I mean, hardware integration is possible with almost any imaginable system has that option, but that takes extra hardware, so it's not advantageous. So, an SDK software integration to any package, Honeywell or otherwise, is possible.
Okay, and if there are any other questions that we may have missed, we will get those answers off to you. And I guess, Stuart, if you want to close things up, and we'll move on.
Yeah, okay, well, perfect. So once again, thank you all for attending. Thank you all for the very good questions. And, you know, feel free to contact Senstar to learn more.